In this video, we'll learn about the so-called working together problems. Before we get into an actual problem though, let's make sure we understand the underlying concept. First of all, if it takes you 3 hours to do a job, what fraction of the job do you get done each hour? Well, we can imagine taking that job and splitting it into 3 equal pieces, and imagining that we get one of those pieces done each of those 3 hours. So that means we get a third of the job done in the first hour, a third in the second hour, and a third in the third hour. And that means that we get 1/3 of the job done in each of those 3 hours. Similarly, if we can get the job done in 5 hours, then we can imagine splitting our job into 5 equal pieces. And in each of those hours, we get 1/5 of the job done. So following the pattern here, if it takes us t hours to do a job, then the fraction of the job we can get done each hour is going to be 1/t. And that works even if t isn't a whole number. It really doesn't matter what kind of number t is, it's going to be 1/t. Okay, so now let's work on a real problem. It takes Andy 40 minutes to do a particular job alone. It takes Brenda 50 minutes to do the same job alone. And we want to know how long would it take them if they worked together. So let's organize our information in a chart. So first of all, we know that it takes Andy 40 minutes to do the job. And that means, just like we were talking before, in each minute, he gets 1/40th of the job done. Similarly, Brenda takes 50 minutes to do the job. And so in each minute, she gets 1/50th of that job done. Now together, we don't know how much time it takes them to do the job, so we'll just call that t. But what we do know, again thinking about what we talked about before, is that in 1 minute, they will get 1/t. That'll be the fraction of the job that they get done in each minute. But since they're working together, the amount of work that Andy gets done in 1 minute, plus the amount of work that Brenda gets done in 1 minute, if we add those two amounts of work together, we'll get the amount of work that they get done together. So if we add 1/40th to 1/50th, we will end up with 1/t. And that gives us an equation that we can solve. Here's what that equation looks like. 1/40th plus 1/50th equals 1/t. And now let's try to see what we can do with the left-hand side there. Let's find a common denominator for those two fractions. There's lots of choices, but let's use 200. It's probably the smallest that we can do. So we can get the first fraction to have a denominator of 200 by multiplying top and bottom by 5. That gives us 5/200. And for the second fraction, we can multiply top and bottom by 4, and we end up with 4/200. And that still equals 1/t. So now we can combine the two fractions now that they have the same denominator. So we get 9/200 equals 1/t. We want to get t by itself, so we'll do a couple operations here. Let's multiply both sides by t. On the right-hand side, the t's divide out. And so we get t times 9/200 equals 1. We want to get rid of the 9/200, so let's multiply both sides by 200/9. On the left-hand side, the 200 and the 200 divide out, and the 9 and the 9 divide out. So we end up with t equals 200 divided by 9. We could plug that into our calculator just to see if our answer seems reasonable, and we end up with 22.22, and the units here would be minutes. And again, that seems pretty reasonable. It took Andy 40 minutes to do it alone, Brenda 50 minutes to do it alone, so for it to take about 22 minutes for them to do it together, that seems in the ballpark. And that's our answer.